Hello, this is Professor Urbis White. Today we are going to learn how to solve systems of equations using a method called addition method. Sometimes you will also hear the word elimination method. And we are going to do two variable systems. And let's go. Okay, I'm giving you the steps to do this method. The first one is put x and y terms on one side, and I'll go over that with an example. Try to match the coefficients of either x or y, and multiply one of them with a negative one. So let's say if the coefficient of x is 3x, you try to get negative 3x in the other equation. So you try to match only one of the variables. Then you're going to add. That's why this method is called addition method. When you add, you eliminate that variable that has the coefficient like 3 and negative 3. So sometimes that's why it's called an elimination method. And then that will leave the other variable alone, and you'll solve for the other variable, plug it back into one of the equations, and get the first variable. So let's go over it. Okay, here it is. This one says, the first step, put x and y terms on one side. Okay, so I'm going to move the 3x to the left. And this one, I'm going to move this 3x to the left as well. Now, this is what I have. So I moved that 3x to the left, which became negative 3x. And this negative 3x to the left, which became positive 3x. And I changed nothing else. Now, this one says, try to match the coefficients of either x and y. Guess what? They are matching, and these two steps are together. They are matching in such a way that they are the same number, but one is positive, the other one is negative. That's what you want. Then you say, okay, well, add left and right. So let's add left and right. When I add these two, I get 0. When I add these two, I get 2y. And when I add these two, I get negative 3. Okay? Then you can pull this variable out of that. Does it make sense? All right. So y is equal to negative 3/2. So what is the last step? Put in the y in there in one of the equations and solve for x. So let's put negative 3/2 equals, I'm using the first equation, 3 times x plus 1. Now let's take out the 1. So you have negative 3/2, negative 2/2, which is negative 1. That's going to equal 3x. These two will go. And this one, negative 3/2 minus 1, which is negative 3/2 minus 2/2. And what does this give me? Negative 3, negative 2, so that's negative 5/2 equals 3x. And then I divide both sides by 3. I will get x equals negative 5/6. So let's write the equation. Solution is then negative 5/6 for the x-coordinate and negative 3/2 for the y-coordinate. And you are done. All right, let's go to the next example. Let's say I'm doing the same steps. I need to move everything to the left now. Negative 2x plus y equals 1. And then I move this to the left again. Negative 2x plus y equals negative 1. So I moved everything to the left, first step. And now, one it has to be negative, the other one has to be positive. So what am I going to do? I'm going to multiply this whole thing by negative 1 and rewrite. So the first equation was negative 2x plus y equals 1. The second equation is negative 1 times negative 2. That's 2x Negative 1 times y is negative y equals negative 1 times negative 1. That is 1. Now let's add. You're going to end up 0 plus 0 equals 2, which is 0 equals 2. What does that mean? What that means is the left and the right don't match. And there's nothing on earth you can do to make them match. What does that mean? There's nothing on earth you can do. So, there is no x and y. So, no solution. Or you can put the empty set. Okay, let's do another one. Let's move everything to the left on the first one. Negative 2x plus y equals 1. Let's move everything to the left with the next one. Negative 4x plus 2y equals 2. I need to match the coefficients, and one coefficient has to be negative, the other one positive. So this one is positive 1, this one is 2. So I'm going to multiply the top by negative 2 and rewrite. 4x minus 2y equals negative 2. All right. And you have negative 4x plus 2y equals 2. So let's add. You're going to end up with 0 plus 0 equals 0. 0 equals 0. What does that mean? 0 is always equal to 0. So it always works no matter what you do. And when you actually look at these two equations, they're identical. You don't have two equations. You actually have one equation, and you're trying to figure out two things. You can plug in a bunch of different numbers and make that work. What does that mean? Infinitely many solutions. All right? So you have infinitely many solutions other than, no solution. So let's do an example where I have a genuine situation of one answer. So let's do the first one. I'll rewrite here so you can see the steps. Y equals 3x plus 1. I'm going to subtract 3x from both sides. You have negative 3x plus y equals 1. That's the first equation. I'll do the other one. 3y minus 2x plus 2 equals 5. Let's subtract 2 from here. And these two will go, and this is going to be 3. I'm going to write the negative 2x first, and then 3y. Do you see it? So these two, I'll line them up. Negative 3x plus y equals 1. Negative 2x plus 3y equals 3. Well, let's try to match the y's. So I'm going to multiply the first equation by negative 3. What are you going to get? So you're going to have 9x minus 3y equals negative 3. And second equation, negative 2x plus 3y equals 3. That stays as is. Now let's add. 9 minus 2, that's 7. These two will give you 0. And this one is 0 as well. Let's divide both sides by 7. I'll get x equals 0. All right. So if x is 0, let's plug it into this equation. I'll take y equals 3x plus 1. Y is what when x is 0? Y is 1 when x is 0. So what's the solution? The solution is 0, 1. And this is the end of this method.